Just now, a Spanish-English bilingual caller got stuck because our ASR NLU misheard pago as pago and looped.
That's not a glitch. It's proof our text-first stack is failing real-world accents and costing us containment.
If we keep rebuilding intents from transcripts, latency stays above 300 meters and sentiment cues get lost.
Then we need a speech-native platform that processes audio end-to-end, or we'll keep bleeding customer.
Right. So welcome to this deep dive on the CRM Position podcast.
Yeah, glad to be jumping into this one.
Okay, so think about the last time you watched, like, a really brilliant stand-up comedian.
Oh, sure.
You know, the timing, the pauses, the sarcasm, the exact millisecond they shut down a heckler in the back of the room.
It's all about the delivery.
Exactly. But now imagine trying to rate that performance, but instead of actually watching the show, someone just hands you a black and white court transcript of the words they said.
Yeah, I mean, you get the raw text, sure, but you completely lose the hesitation, you lose the tone.
You lose the entire context of the room. And that is exactly what enterprise contact centers are doing to you, to your customers, right now.
Every single day.
We are taking you straight into the war room today to unpack what is honestly a massive structural failure across the industry. And that's this total obsession with text-first AI pipelines.
It's a fundamental misunderstanding of the medium.
Right. We're treating a customer's voice like it's just this messy, disposable wrapper for a transcription. And it's breaking the customer experience at scale.
It really is a critical operational blind spot because, I mean, for years, the industry standard has just been to take a customer's voice, jam it through an ASR, an automatic speech recognition engine, to turn it into a flat string of text.
What is typewriter?
Yeah, exactly. And then you feed that text into an NLU, your natural language understanding engine, to try and figure out what they actually want.
Which sounds logical on paper, I guess.
On paper, maybe, but from an engineering standpoint, you're treating audio as a temporary input. And when you look at the messy reality of human speech in a live contact center, that entire pipeline is structurally bankrupt.
Bankrupt. Okay, I want to look at the sheer mechanics of why this is failing on the operations floor. Let's start with the latency issue.
Right.
Because looking at the research, there is a hard claim here that these text-first stacks have a structural latency floor of over 300 milliseconds.
Minimum. Usually worse.
But I have to ask, I mean, is 300 milliseconds really enough to bleed customers? It sounds so fast.
In a human conversation, absolutely. I mean, 300 milliseconds is an eternity.
Really?
Yeah. Human beings naturally take conversational turns in about 200 milliseconds. If you go over that, you hit the threshold of dead air.
Wow.
So let's look at exactly why legacy stacks create this bottleneck. It's a completely serial process.
Step by step.
Right. The customer speaks, the system has to buffer the audio, then wait for a pause to detect the end of the sentence. Then it sends that chunk of audio to the ASR, waits for the ASR to guess the words, generates a transcript, serializes that text, hands it over to the NLU.
Which takes more time.
Exactly. Then it waits for the NLU to parse the intent, and only then can it even begin generating a response.
So it's basically a relay race, where every single runner has to completely stop, fill out a form, and then hand the baton to the next person.
That's a great way to put it.
And by the time the AI actually generates a response, half a second has passed. And in a real phone call, half a second of dead air feels like you've been hung up on.
Well, what does the customer do? They think the bot didn't hear them?
Right, so they start talking again.
Just as the bot starts replying, it creates a collision.
A total mess.
But consider the alternative, end-to-end neural speech models. Something like the OASYS architecture from SoundHound AI is a prime example of this shift.
How does that bypass the relay race?
It just completely skips it. The acoustic wave, the actual raw sound of the caller's voice, goes directly into the neural model.
Without making a text file first.
Exactly. It detects the intent directly from the sound itself. It never bothers writing down a transcript to figure out what to do.
Wow.
That cuts intent detection latency to under 150 milliseconds. Even in really noisy environments, you just completely eliminate that structural delay.
Okay, I totally get the speed advantage. But I want to talk about accuracy. Because in our cold open, we mentioned that Spanish-English bilingual caller.
Ah, right. The code switching problem.
Yeah, where the bot loops. What is actually happening inside the text-first model that makes it crash when someone seamlessly code switches like that, like mid-sentence?
Well, it comes down to something we call phoneme-level state retention.
Phoneme, meaning just the basic unit of sound, right?
Right, a distinct sound. When you force audio into a traditional ASR, that ASR is hard mapped to a specific language dictionary.
Like English.
Usually, yes. So if it's an English ASR and a caller says pago, which means payment in Spanish, the ASR literally does not know what to do with those phones.
Because pago isn't in its dictionary.
Exactly. It's desperate to find an English word that fits, so it guesses. It transcribes pago as, pogo or cargo.
Oh, man. So the NLU down the line receives the word pogo, has absolutely no idea why the customer is talking about a pogo stick during a billing call, and the intent just fails entirely.
Precisely. Because the very act of transcribing the audio stripped out the acoustic context. The system committed to a hard text token, and that token was just wrong.
It locked in the wrong guess.
Yes. But a speech-native architecture retains that context directly from the acoustic stream. It doesn't need to commit to a discrete, spelled-out word before it understands the intent.
It's almost like trying to read a really blurry font.
Okay, yeah.
If a text engine is trying to read it, it has to commit to guessing a specific letter. And if it guesses a C instead of an E, the whole word is misspelled, and the system fails.
Right.
But an acoustic engine steps back and looks at the shape of the entire word, the actual sound waves over time, so it doesn't get tripped up on one slightly distorted piece of data.
That is a perfect way to visualize it. And the data really backs up why this matters on the floor.
What are we seeing?
When you run proprietary acoustic training on contact center specific corpora, meaning you train the AI on the actual audio of your insurance claims or your retail orders, you see a 15% relative gain in intent accuracy for heavily accented English.
15%.
Just by dropping the generic ASR NLU stack.
That's massive. We aren't talking about vanity metrics here. That's millions of dollars in contained calls that otherwise would have escalated to a human agent, purely because the bot couldn't handle a regional accent.
Absolutely.
But let me push back a bit on the operational reality here. What happens when a caller is just angry and interrupts the bot mid-sentence?
The barge-in scenario.
Yeah. Does a speech-native architecture actually handle the mechanics of a barge-in better? Or is it just, processing the interruption faster?
No, it handles it entirely differently at a structural level. Think about a text-first agent. When a customer interrupts, the system literally crashes its current process.
It freaks out.
Yeah, it has to abort what it's saying, dump the text buffer, and restart the ASR listening phase completely from scratch.
Just to catch the new audio.
Right, and this creates massive false positive retriggers. The bot stops just because someone coughed or a dog barked in the background.
Oh, I've had that happen. It's infuriating.
But speech-native barge-in handling preserves the continuous acoustic stream. It hears the interruption natively without having to reboot some text buffer.
And because it's analyzing the sound natively, we're talking about prosody now, right? Meaning the pitch, the energy, the speed of the voice.
Exactly. This is where sentiment cues live.
Right.
If I say the word fine with a low, even pitch, it means I agree. If I say fine with a high, sharp pitch, it means I am incredibly frustrated.
But a text transcript just says the word fine in both cases.
Exactly. A speech-native model natively extracts those prosody-based sentiment cues. If a caller's volume spikes or their speech rate accelerates, the model detects that real-time escalation triggered directly from the acoustic wave.
So you don't need to route a flat transcript to a separate text sentiment model to, guess if they're angry.
You don't, and that single architectural shift cuts false negative escalation rates by roughly 12%.
That is wild. You are quite literally hearing the frustration instead of guessing it.
Exactly.
Okay, let's shift gears from the underlying theory to the reality of incident response. Because the research outlines 3 specific war room scenarios where operations just completely break down.
Yeah, the failure modes.
Let's start with scenario 1, the logistics company. You've got drivers or factory workers interacting with an automated dispatcher. Suddenly, a forklift drives by.
A classic problem.
The ambient machinery noise exceeds the acoustic model's trained signal-to-noise ratio. Basically, the background noise gets too loud compared to the human voice. What happens mechanically?
The impact is instantaneous. You see a massive spike in the word error rate.
Because it's trying to translate a beep into a word.
Right. The legacy ASR was likely trained on relatively clean studio-quality audio. It doesn't know how to process a forklift beep, so it panics and tries to force that beep into a text token.
It hallucinates words that aren't there.
Exactly. In the data, we've seen this specific failure drop first call containment from 78% straight down to 42%.
just from background noise. That is a catastrophic operational failure.
And the traditional fix for that is brutal.
Yeah, you have to pull the audio logs, manually label the noisy data with human reviewers, retune the entire model, run tests. You are waiting months just to fix the forklift problem.
Which is completely unacceptable in a live enterprise environment.
Right.
The speech-native advantage here is continuous self-learning. Platforms like OASYS don't need humans to transcribe the new noise. They update their acoustic models directly from the live call audio.
So it learns on the fly.
Essentially, yes. They cluster the new acoustic patterns, mapping those sounds directly to intents and adapt to that environmental drift in a matter of weeks, entirely bypassing the manual data labeling bottleneck.
Okay, that self-learning feature makes total sense for a noisy factory floor. But what about scenario 2? What happens when the environment is dead quiet and the voice itself is the problem?
Ah, the uncovered dialect escalation.
Exactly. Say you roll out your bot and suddenly you realize a specific regional dialect was missing from your training data. A caller with a heavy southern drawl or like a Scottish brogue is trying to read out a complex alphanumeric policy number.
What you get is a systematic misrecognition of critical entities. The text engine just keeps guessing the wrong letters.
E becomes B, A becomes 8.
Right. So the system loops. It asks the customer to repeat the policy number 3, maybe 4 times.
Which destroys your metrics.
It severely bloats your average handle time, your AHT, which, as you know, is the absolute holy grail metric for contact center costs.
Yeah, and the call inevitably escalates to a human agent anyway, but now you have a furious customer on the line.
Exactly. And in a traditional setup, you wouldn't even know it was an accent issue causing the loop until a downstream speech analytics pipeline tagged the dialect days later.
You're just reacting to the failure in the rearview mirror.
Yes. But with a speech-native platform, real-time accent adaptation neutralizes the discrepancy on the fly.
Because it's not forcing words into a dictionary.
Right. It's continuously analyzing the phonetic shape of the words, so it adjusts dynamically, preventing the escalation and saving your AHT without needing some retrospective analytics team to flag your blind spot.
That brings us to scenario 3. And this one makes IT security sweat.
Oh, the PCI DSS scope creep.
Yes. For anyone not deeply in the weeds on compliance, PCI DSS is the payment card industry data security standard. It's the strict set of rules governing how you handle credit card data.
It is unforgiving.
Totally. So let's say a text-first bot keeps mistranslating a specific phrase during a payment flow. An engineer decides they need to troubleshoot. But because the text transcript is failing, they need to hear what the caller is actually saying.
Right.
So the engineer inadvertently logs the raw audio to a debug bucket.
And right there, you have a massive problem. I mean, even if absolutely no text transcript is stored in that bucket, capturing and storing raw audio during a payment flow violates PCI DSS if card numbers are spoken.
You just triggered an immediate compliance audit finding for card data exposure.
Exactly.
And the irony here is incredible, right? Engineers create these audio debug logs because the text pipeline failed.
Yes.
But by avoiding intermediate transcripts entirely with an end-to-end platform, you actually minimize PCI DSS exposure in payment flows from the start.
Because you don't have this vulnerable intermediate text artifact failing all the time.
Which naturally reduces the temptation for engineers to create parallel raw audio buckets just to figure out why the bot crashed.
It's a prime example of how architecture dictates security. But, recognizing the problem isn't enough.
Right.
If you are a CRM leader or a platform VP, you can't just talk about the theory. You need a strict deployment matrix to rip out the old and deploy the new.
So let's build that playbook right now. We dug through the research, and there's a very clear 5-step operational mandate here.
Let's do it.
Step 1, you have to overhaul your hiring and org chart budgets.
This is where it gets painful, but it is necessary. If your AI team is entirely comprised of NLU specialists, prompt engineers, and text-based data scientists, you are structurally misaligned for the future of enterprise voice.
You have to shift the headcount.
The new mandate requires speech signal engineers and acoustic data scientists who actually understand audio waves, not just text tokens.
But wait, let me challenge this from the perspective of a QA manager. For step 2, if I don't have a clean text transcript to score against a rubric, how on earth do I run quality assurance on a bot?
It's a huge shift.
Right. My entire dashboard is built on reading what the bot heard.
You have to shift your entire paradigm to audio-centric metrics. Your QA teams can no longer just look at a spreadsheet and ask, did the bot output the correct text token?
So what do they look at?
They must now calibrate for wake word confidence and prosody variance. Did the bot correctly interpret the acoustic energy of the customer? Did it recognize the frustration? It
Wow.
requires entirely new tooling and a complete retraining of your QA personnel.
That is a heavy lift.
Yeah.
And it brings up step 3, which is the elephant in the room regarding vendors.
A lock-in.
Yeah. These end-to-end neural speech models are proprietary. They're essentially black boxes. How do procurement teams handle the vendor risk here?
You have to mitigate it legally before you ever deploy. Procurement and IT security must aggressively negotiate escrow clauses for the acoustic model weights.
So when you say escrow, you mean legally holding the actual model weights, the underlying math of the neural network in a third-party vault.
Yes.
So if the vendor goes bankrupt or jacks up licensing fees, you don't lose the brain of your contact center.
Precisely. You cannot be left without the acoustic engine that powers your entire floor. You must cap your exit cost risks by ensuring you have access to those weights in a worst-case scenario.
Okay, so step 4. Assuming we secure the model, where do we deploy it? The mandate from the research is clear. Execute voice-native omnichannel, not chat-first omnichannel.
Right. Stop trying to take a text-based chatbot and force it to speak over the phone.
It doesn't work.
You need to deploy a single voice-native agent across your telephony, your in-vehicle infotainment channels like car dashboards, and your physical kiosks.
Because you aren't constantly translating audio to text and back to audio.
Exactly. You preserve high voice fidelity across all those environments, and practically speaking, it slashes integration effort by 40%.
Because you aren't trying to retext the agent for every single new acoustic space.
Right.
Which leads to step 5, the final operational move. And this one hits the bottom line directly. If you are a Contact Center Tech VP and you successfully deploy a speech-native architecture with sub-150 millisecond latency.
And massively higher first call containment.
Right, you have to rewrite your outsourcing SLAs.
Yep.
You cannot keep paying your business process outsourcers the same rates for automated flows.
You have to go back to the negotiating table.
Because you're basically subsidizing your own latency under the old model.
Exactly. You demand tighter guarantees. Specifically, you lock in an average handle time of under 8 seconds for automated routing flows.
8 seconds.
Because the structural latency of the ASR NLU pipeline is gone, the conversation is inherently faster, and your BPO contracts absolutely must reflect that new operational reality.
All right, so we've built the playbook, we've explained the mechanics, but it is time for the harsh truth. We look at the data across the industry. What are enterprise leaders getting completely wrong right now? Give me the controversial take.
The uncomfortable truth is this. Investing in any text-first agent builder for contact center voice use cases right now is a massive strategic misallocation of capital.
Okay, let me play devil's advocate here. A lot of VPs listening have already sunk millions into their current text-based generative AI stacks.
I know they have.
Can't we just patch them? Can't we bolt on a faster ASR or route the audio to a separate emotion detection API on the side? Like, can't we just engineer it to be good enough?
No, you absolutely cannot.
Really?
You cannot close the latency and accuracy gaps of text-based stacks without prohibitively expensive re-engineering. It is a fundamental architectural ceiling.
Goes the dead end.
Completely. Continued spend on chat-centric platforms for the voice channel is a waste of budget. Within 24 months, that architecture will be entirely obsolete.
Because the standard is shifting.
Because voice-first, speech-native latency, that sub-150 millisecond barrier, is going to become the uncompromising default expectation for enterprise AI. If you are patching a text pipeline today, you are funding legacy tech.
That is a sobering reality for a lot of platform leaders out there. So we're going to leave you with 3 concrete next actions war room directives you can execute this week.
Number 1, audit the true end-to-end latency of your current ASR NLU pipeline.
Do the actual math from the moment the customer stops speaking to the moment the bot actually begins its reply. If that clocks over 300 milliseconds, flag it for immediate architectural review.
Second, run a containment drop-off analysis, but isolate it entirely to heavily accented callers or bilingual interactions.
Stop looking at your global averages. Expose the actual accuracy tax your text-first stack is placing on diverse caller populations.
And third, force a compliance review of all raw audio debug logging across your contact center.
Find out exactly where your engineers are dumping audio to troubleshoot text failures and shut down that PCI DSS scope creep before your next audit.
Which brings us to our final uncomfortable question for you to mull over.
Let's hear it.
If your text-based bot is discarding the pitch, the energy, and the hesitation of your customers, how many silent escalations are you funding right now without even knowing it?
That is the multi-million-dollar question. And to stay ahead of real CRM and AI platform shifts exactly like this one, you need to subscribe to the CRM Position podcast.
It's the only way to keep up.
This is where you come to hear complex, executive-level operational topics broken down without the hype. We cut through the marketing narrative so you can understand the actual state of the art in this industry. So make sure you are subscribed to the CRM Position feed, and we will catch you in the next deep dive.